the two types of ways that plants like to reproduce, okay, is through self-pollination, okay? So self-pollination, like the name indicates, kind of does it with itself, okay? So the plant will actually transfer pollen to its own style and stigma, okay? And then basically it's expected that the offspring are identical to the parents. So this is similar to kind of cloning because we consider this to be what type of a reproduction system? Asexual reproduction, okay? So maybe you guys want to add that. So this is a form of asexual reproduction. Okay, but of course, we're not going to get any sort of genetic variability if we only rely on asexual reproduction. It has to absolutely cross-pollinate in that sense, okay, where we actually take the pollen and transfer it from one plant to the other one. So bees, super, super important in actually participating in that process because as they pollinate each flower, they're actually going to distribute that pollen that kind of gets stuck onto their fuzzy little bodies and then kind of keep on mixing up those genes. So that's really, really extremely important as a process in plants to be able to do that cross-pollination by the help of animals and especially insects, okay? Who's ever seen Bee Movie?
Yeah.
Yeah. I hope she's bee-ish. Anyways. Alright, so what Mendel saw was the fact that he took a tall pea plant, okay, and he took a short pea plant, okay? So, whenever we take an original parent, okay, we call this the pea generation. So this is the parent generation. Okay, so we will shorten that, and eventually you guys might actually see that as being the parent generation of that particular plant, okay, or that plant ancestry, I guess. Okay, so what Mendel saw is that once he cross-pollinated these two different types of plants, you can only do cross-pollination technically in this sense, okay, what he saw was that all pea plants that were produced by crossing these two were all tall pea plants. So we call this the F1 generation, okay? So this is called the filial generation, okay? So it's basically like the first set of babies, okay? So filial generation, F1, just simply means that once you've crossed some original parents, F1 is like the first set of babies, okay? So even further to that, as Mendel wants to make more pea soup, he wanted to make more peas, okay? Basically, because all those tall pea plants kind of showed up, he wanted to actually further try to see what the next generation would produce. So he took an F1 tall pea plant, so that means it was all of these guys right here, okay? Another F1 tall plant, and what he found was that eventually the general trend was that there was 3 tall plants and then 1 short plant produced per 4, I guess you could kind of say, per 4 pea plants that were just produced ultimately, okay? So whenever we see the second F2 generation, okay, that just simply means that we've got another filial generation, but it's kind of like the second generation. That's what's denoted by the little 2 on the F, okay? So filial generation, okay? So what's odd is that in the first generation of pea plants that were produced, everybody ended up tall. But yet in the next generation after that, okay, the lost trait or the short trait actually showed up in the second generation. And that's kind of where he started thinking, what the heck is going on in here, okay? And that's how he kind of ended up with that, okay? Now the next thing too, you're going to recognize a 3-to-1 ratio is evidence of a trait governed by something called complete dominance, okay? Now the last time you would have heard of this would have been actually grade 9, okay? So you guys remember like the little rabbits that reproduce, there's a black bunny and a white bunny, and then you'll produce a black bunny for some reason instead of like a gray bunny or whatever, okay? So complete dominance just means that one of the traits is actually going to overpower one of the other traits, okay? So the next little section here